This is Precalculus Math Analysis, section number 7.3. We're talking about Kramer's rule. This is part 3 of the notes. So what you are seeing now, that is what we completed last time. We did an application with finances, and we also used graphing calculators with matrix operations to solve that problem. And so, our third part of the notes begins with another way to solve systems. And that's going to be through Kramer's rule. C-R-A-M-E-R, Kramer. It uses determinants. So, given a system of two equations with an augmented matrix, all right, this augmented matrix is going to be all letters A, B, C, D. With, say, like 2x plus 3y equals 5. Then the A is 2, the B is 3, and the E is 5. So these are coefficients. We are going to take the last column and replace the first column. And that would give us a square 2x2 matrix with elements E, F, B, D. Notice that the Y column stays the same. Okay, this is the X column that we're changing. And we're going to call this matrix A subscript X. Then I'm going to do the same thing with the Y column. And I'm going to have another 2x2 matrix with elements A, E, C, F. I'm going to call that one A subscript Y. And then remember that this matrix right here, we're going to call A. That's the coefficient matrix. So we have three 2x2 matrices. And what's going to happen is X is going to be the determinant of the A subscript X matrix. That's going to be ED minus FB divided by the determinant of the A matrix, AD minus BC. We're going to notate this another way, and we're going to write AX over A. Okay, so please notice that this stands for the determinant, that so-called absolute value symbol. The Y will turn out to be the determinant of the augmented Y matrix divided by the determinant of the regular A matrix. And let's call that determinant of the augmented Y matrix over determinant of the coefficient matrix A, where this notation right here means determinant. And that makes us happy. Because now we have yet another way to solve a system of equations using Cramer's rule. Solve the system of equations 4x minus 3y equals negative 14, negative x minus 5y equals negative 8. All right, so step by step, first I'm going to form the regular coefficient matrix. Then I'm going to form the augmented x matrix. Replace. Keep the y coefficients the same. Then I'm going to form the augmented y coefficient matrix. Keep the x's the same. Replace. Next step, find the determinant of each of those. Right, just writing out all of my work. That should be 46. And then determinant of the final augmented y coefficient matrix. That should yield an answer of negative 46. Step number 3. It's going to be the determinant of the x matrix over the determinant of the regular matrix. So, x should equal (46) over negative 23. And that's negative 2. Y should be the determinant of the augmented y matrix over the determinant of the A matrix coefficient. So that should be negative 46 over negative 23, positive 2. There you have it. We now have 3 ways to solve systems. Cramer's rule can be extended to any square matrix of n dimension. So let A be a coefficient matrix of a system of equations size n by n. Let X be the variable matrix. It must be true from previous notes on the lesson that the matrix equation AX equals B. Therefore, by Cramer's rule, the solution to the system will be the first augmented variable matrix over the regular one, comma, the second augmented matrix over the regular one, comma, the third augmented matrix over the regular one, and so on, up to n dimensions. All right, so remember this is a capital X, and in our solution, that this is Cramer's rule right here. This really would be like AX, AY, AZ, AW, AU, however many variables we have. We can solve them all. Here is a challenge for you. Solve the system of equations using Cramer's rule. Alright, this is going to take us a little while, but we definitely don't want to do this by hand. We do not want to find 3x3 determinants of 4 different matrices by hand. So this is going to involve the graphing calculator a little bit. First, let me start off writing out all of my different matrices. Be sure to recognize that there should be a 0 for that third equation. Alright, so for that equation I replaced the x column. For the augmented y matrix, I replaced the second column. And then for the z matrix, I replaced the third column. Let's move this one over here. Nice and organized. Okay. Next, let's bring up the graphing calculator. Alright, so I have gone ahead and put all matrices into the calculator already to save a little bit of time. Alright, at this point, if you think you can try the problem, pause the video, enter all the matrices in, and then see if you can find the determinant of each matrix, and then use those determinants to find the value of each variable. Okay, here we go, step by step. Now, I have, for example, matrix A. I have that matrix in 2, -4, 1, -1, 3, -4, 0, -5, 2. Hopefully I put them all in and it works out nicely. But in order to find the determinant of this matrix, I'm going to press second matrix, but I'm going to go to math. And then very first one there, it says DET parentheses determinant. And then second matrix A. Here's a really nice function in the calculator. Enter. We have our determinant, -31. I'm going to go ahead and do that for all 4 of my matrices. Now, AX is actually going to be my B matrix in this calculator. So B. Enter. Let's next find the determinant of AY, which in my calculator is matrix C. Next one. My Z matrix is in the calculator as matrix D. That's the majority of the graphing calculator work. All right, now x should be negative 93 over negative 31. It's going to turn out to be 3. Y should be 31 over negative 31. Z should be 124 over negative 31. All right, there you have it. We just did a challenge problem. Keep in mind that it does take a long time to use that graphing calculator, put all that information in, and then find the determinants. Be sure to comment on this video, and then have a nice day.